So thank you everybody for joining us today for a virtual Linux Foundation Decentralized Trust meetup. Today we're going to be talking about using Rust to interact with a Hyperledger Fabric network. This is attached to a lab that Arne has started. So he's going to explain what the lab is, how you can use the code, and how you can get involved. And with that, Arne, please take it away.
Yeah, hello everyone. Nice seeing you. So we're going to talk about some Rust libraries which will be added to the Linux Foundation Decentralized Trust. I've decided to start implementing some Rust implementations for the Hyperledger Fabric network. Currently, there are some already on the market. I think Golang, Java, I think JavaScript was one of them too. But of course, one of the most important languages out there was missing. So this was the motivation to start implementing the Hyperledger Fabric SDK for Rust. Let's get see some slides first. So, yeah, why Rust? Of course, there are many other languages you can choose from. As I already mentioned, there are already some bigger languages implemented. But Rust is one of the fastest growing languages out there, and it's of course because of its memory safety, because of its performance, it's a really good option to choose a language. But some of the properties I want to talk about specifically, because I have some visions to the library we are implementing for the Hyperledger Fabric. One of them is WASM, WebAssembly. WASM support. This is especially interesting because many libraries are starting, the front-end libraries are starting to rise for WASM. For example, Deoxys is one of the libraries I personally really like to use. Eguri is one of them, where you write some Rust code and compile it to WebAssembly and then deploy it on the web. So, of course, here the use case would be that this library we are implementing here would be compilable to WebAssembly so that you can sign your messages in the browser on the edge and don't have like a man in the middle in there. This is, of course, not that easy because WebAssembly is pretty restrictive. But I'll see how we can go to there. Of course, IoT edge computing is also a big thing. If you want to have a sensor signing some data, Rust is, of course, a pretty good choice to do that. Efficiency, of course, already talked about this, a big point. Code diversity. Yes, this is like really important. So in many blockchain networks, you actually have, you try to have as many languages included as possible. Especially for the node software, this is really important. I think Ethereum does this. They have their node software implemented in several languages. Just because, if you have a bug in one of the node software, it is less it's less probable that it happens into the other languages too. So if the Ethereum nodes in Go crashes, it's not sure that other nodes in different languages will crash too. So having different implementations of a library or the node is, of course, super important in blockchain systems to ensure that the network is operable. Of course, we are not implementing here the node software currently, just like a library to the network. But of course, this kind of applies here, that we try to get a bigger code diversity to adopt to different use cases. And one personal big thing I really like, especially about Rust, is the serialization and deserialization. I don't know if you guys worked with Rust before, but in my personal opinion, it's really nice working with it if you serialize and deserialize things, if you have to do that. The crates, server crates, server JSON crates are really well implemented. And this is especially interesting if you have assets on the chain. As you may know, we have in the Hyperledger Fabric network, we are working mainly with assets. And these assets can be serialized structs, for example, written in Rust. So you can just define like a struct, serialize it into a JSON and put it in the asset. And if you have the code for it written in, so the crate, the library written in Rust, and also the chain code written in Rust, you have a situation where the serialization, deserialization happens with the same logic. So it's more fail-proof. Sadly, currently, the chain code implementation is not yet implemented. So we have the GitHub repo for that. I think it is, let me think, Fabric chain code Rust. I'll send the link into the chat later on. I have it somewhere. I actually have it on the next slide, I see. I will start implementing it soon, so that we have a base we can work on. Today, we will mainly talk about the fabric-sdk-rust, so the connection to the network, not the chain code in there. This is like a really nice trait if both of it is implemented in Rust. Maybe I can show an example later on. So let's get into the repo, I would say. Currently, sadly, it's not on GitHub Live yet. I have some issues with the GitHub rules there. So currently you won't see anything on the repo yet. But this is like the current status you're seeing here. I'll upload it as soon as this meetup is over. So you can have a look yourself on the code and maybe do some programming there. How do you continue? Yeah, so let's talk about a bit how you can set it up and then run your own tests, for example. And then we talk about how you can get involved and what are the next steps for the project. And yeah, any questions at this point? You're, of course, open to write it into the chat. Oh, an overview of what is Fabric. Sure, I haven't prepared for that. So sorry if I didn't introduce the Fabric alone. I kind of assumed that that most people who are joining this meetup are already kind of into Fabric, because this is like a special implementation for it. So just to show short forms, just so that we don't get like we don't expand too much, but maybe we can later on discuss more about that. Hyperledger Fabric is a permissioned blockchain. So the difference about other blockchains, permissionless blockchains like Bitcoin and stuff like that, is that it's a closed group network. So just like a closed party is allowed to join the network. And it's based on assets and not on any coins. So you don't have an actual value in the chain. But I'm not sure actually if this is still the standard. I'm not sure if like some expansions actually add coins to that. But if you get like the standard native chain, you only work with assets which are like just like some bytes on the ledger. So this is mainly for B2B business stuff, and not for getting your NFTs, selling them, and something like that. So this is a bit special. Maybe not that what you usually see there out in the wild. But I think this sums it up. Okay. Any more questions? I'm sure if you have more questions about the Hyperledger Fabric network itself, we can later on talk about it more. If there are not any questions, I'll continue how to get it running. So the versions we are currently implementing is for the most recent version, so for 2.5. Of course, I can't say what will change in the next release. Thanks for the correction for the CD comment. So this is the work in progress on the current release we are having. I think soon there will be a new release. I'm not sure which version it will be. I think 2.7. But this is like still under heavy development. So if there would be big changes, I think it will be immediately implemented. So maybe it can be the case that 2.5 will actually not be supported. But let's see. This is like in really early stages. So if you go to the code later on, you'll see that like just the most basic chain code interaction is implemented. And not actually more than that. Some tests are written, but yeah, you'll see it. Okay. So if we go to the README, it's not like that much in there. As I said, this is not currently online. I'll upload it after this meeting. So this fabric SDK-rust, it's actually pretty easy to set up. You just have to clone the Git, CD into it. What you have to do, the tests actually read some environment variables in a .env. So you have to copy that to be accessible. And then after that, you have to execute this git command. So the communication to the Hyperledger Fabric network is actually running on gRPC. This is like the Google Remote Protocol. gRPC, Google Remote Protocol. Oh, what was it? I don't know what's the actual meaning is currently. Can't tickles me now. Remote procedure call. Thank you. My God. I should have known that. So there are proto files online. So if you look Hyperledger Fabric protos, let's see. Yes, there they are. So we have some protofiles, and there are actually scripts for translating them into other languages. Mainly for the languages I've mentioned earlier, so for Golang, Java, and JavaScript. But not for Rust yet. So if you have some expertise in that, please go and add some Rust support there. I would really appreciate that. Because we haven't implemented Rust support here yet, you have to clone it as a sub-module, update it, and then it will be available in the project directory. Yeah, and after that, the SDK is ready to use. Just be careful when using it. The libraries in there are not safe-proof. So please, and I say it really, please do not use this in production, even if it might work. There are libraries used which are not safe. I'll get to it later on. And of course, this is all not security tested yet. I hope that soon we will have a state where we can say that this is like a usable product, and then we will get it into crates.io too, so that everyone can use it. So currently it's not available there because we are still in the early stages of development. Okay. Let's see, where are we going from here now? So in the current status, we have some tests implemented, just some basic tests. You can run them with cargo test. So what's implemented are the handshakes to the gRPC and one transaction being executed on the chain. So this is a chaincode call to the basic chaincode. And so if you want to run cargo tests, you have to prepare a Hyperledger Fabric network. So to get this going, you can head on to the documentation. I'll post a link into the chat now. And before running any tests, you have to set up your own Hyperledger Fabric network. I'm not sure if I should go into it. Probably not. But the most important thing is that if you want to run the tests, you have to get the basic chaincode running. So let me see if I have the code here. Written in the docs. This have to be it. Yes, using the Fabric test network. So this is really important before you run any tests, that you set up the basic chaincode. So starting a chaincode on the channel. So these are like the commands you have to execute at this point. So am I right in thinking that the chaincode are still going to be written using Go or JavaScript? Yes. So and Java supported too. So as I said, there's us in the moment there are no Rust chaincode implementation yet. I'm working on it. There do exist in repo, but it's empty. But very soon there will be base implementation. No problem. Okay. Let's go back to the setup. So there, the test can be configured through some environment variables. So this is like sadly a bit complicated, but it is needed to get it running. So we have like a bunch of certificates and private keys which have to be set. So, but in the where is it? In the environment default file, if you clone, so if you set up the project in your home directory under Fabric, then you shouldn't have to do anything here. So this is should all work. But keep in mind, if you place it somewhere else, then you need to edit these files. You can also choose another contract in here if you want to, with another function. So this is just using the initledger function in the basic chain code. Nothing special. Yeah. Okay, so let's see where we're going. We are going from here. We have some thoughts here. I'll go over to some files and hopefully explain a bit how this is built. So as soon as you start building this project, there are being some proto files generated. So these are the files generated from the Fabric Protos GitHub. There is a build script down here which generates those files. Currently, this actually is written in an older version than the current Rust version is supported. So lately, Rust 1.90 was being released. I think some days ago or a week ago. And this is only supported for 1.89. So if you have, again, some expertise in proto files, go ahead and update these dependencies. So if you go into here, you see the tonic libraries are being used. The latest version is 0.14, which is supported by Rust 1.90. 0.1.3 is not supported, officially supported by 1.90, but it still works, right? But keep in mind, if you go into these files, the language server from Rust might be complaining about not being compatible with the current Rust version, but it still works, right? So these are automatic generated files, which describes the gRPC interface to the Hyperledger Fabric node. We have in here, this is actually, so if you work on it, this is actually one of the best documentation you can have. I'm not sure, but I think you won't find much in the documentation officially, official documentation from Hyperledger Fabric. Whereas it's most described how the talking is going on in the network, how the gossip is being executed and stuff like that. But the actual like gRPC requests, I think, are not that documented. But if you generate those files, you'll have a quite good documentation about all the structs you need. And yeah. So we are mainly working on these files. So for example, let me see if I find some good. Yeah. So for example, we have endorsement struct here. So an endorsement is a call to the Hyperledger Fabric network where you say, hey, I want to execute this function, for example, in the chain code. and I want to do that, and you endorse this action to the network, and then the peers will sign this endorsement and send it to you back. So then you can like push it to the network that it's being then really executed. So if you want to do such an endorsement, you can just go into the struct and see what's needed for this call. It's fairly good documented, as I said. Sometimes you have to like dig around where to find, for example, the needed bytes for this parameter. So sometimes it's not that obvious what is needed here. But if you read the docs a bit, you'll see what's being asked here. What I often do is to look into the other implementations too. So, for example, there isn't Java implementation. So if you go to the Fabric Gateway GitHub repo, we can go Fabric Gateway. There is currently, for example, Java implementation and JavaScript. I'm not sure. Go is also in there. So that the Rust project is actually in an own repo is quite exotic, but here we are. But if you're familiar with one of the languages, you're free to go to clone it or load it into your favorite editor and to dig around the code. For example, I had a problem with the signature. The OpenSSL implementation doesn't allow low S normalization in elliptic curves. So what I've done is that I've looked into the Java implementation, for example, and see how they've done that. But then after some hours, I've just used another crate to do it for me. Because the OpenSSL library is not that good in normalization to get like the needed parameters. But this is just like an example if you like don't know where to go or what to do. Look into the other implementations, look how they've done it, and then you can like kind of re-implement it. So let's see, any questions from here? The documentation from the port files does end up in... Okay, so there is an documentation. Fabric Protos, perfect. Thank you very much for that. I'll put it, hold on. You can actually have a look into this for a moment. Let's see what you've provided here. So yeah, yeah, so you can actually see the gossip message. Yeah, you can see the files which have been generated. You can kind of see them here again. But I think, in my opinion, that these Rust files are probably still a bit better than that, just because you can directly see with what types you're handling. Because some of them are requesting vector with bytes, and some of them are actually requesting another struct. Well, it is implemented here too. But yeah, do as you like, do as you want. Can we query block data through the SDK? Not yet. So the only function which is actually which currently programmed is to invoke a method on a chain code. It was pretty important to me that this is like the first thing which is being implemented. So like querying for blocks and stuff like that is not yet implemented. But if you want to, go ahead, do a pull request and implement it yourself. Okay. So let's go back to the project. So as I said, orientate yourself to the other projects. So I'm trying to get something Java-like, so like the Java library did working. So what I've done is to create many builder structs, which is quite needed for this because you're working with many structs. So in these protos files, you mainly are structs you find there. So builder classes are probably the way to go. If you have a better suggestion, go ahead, do a pull request, and if it's good enough, we can merge it. So, but this is like the way I'm currently going. And currently, let's see, I have a test project here. Where is it? Here it is. So in the current state, this is like a test project, just like another project which uses the crate. We have some builder classes, actually 2 of them. So we have an identity builder and a client builder. The client builder is the most important one. The third one, a transaction builder, but we get to it in a moment. So this is a bit, I've oriented myself a bit to the Java implementation. It would be nice if you do some contributing that you will orientate yourself at this too. Of course, if you see some things you can do better, go ahead and do it. One example would be the really flat Java hierarchy they've done here. So I already say that, please don't. Some packaging, some abstraction would be really nice. But I think that that this is hopefully kind of obvious that you should go this way. But yeah. So in the current state, you can construct, this is the one here. So in the current state, you can get an identity builder and build an identity, pass it to the client builder. So the client builder is actually the one which does the talking to the, not especially, but which packs all the needed information. So for example, we have an identity, of course. We have a signer, which we need to sign the messages. And after that, we have a working client, just need to connect to it, and then it's ready to go. From there, we are able to build the transaction builder, where we set some parameters for the chaincode call. This is not, how should I say it? This is not how it's actually should go currently. So probably if we want to implement it, we should do something more specific than just transaction builder. But this is just like doing the first abstractions for the first implementation. And then you can define the channel name, chaincode ID, the function name. We also have a function to put some arguments into it. But this is just like dump call to a function and then get a result and read it. And after we've built this, we get a prepared transaction. So as soon as we hit build, this will prepare everything to get the message ready to be sent to the Hyperledger Fabric network. And then after that, .submit pushes the endorsement to the network. And after the endorsement, it will actually then finally submit the block to the blockchain. So if we execute this, this will successfully initialize the basic chain code. And by initialize, I mean execute the function initialize. So, just to see a bit from the codes. So we have these 4 tests currently. The first 3 are just handshakes to the different nodes. It's pretty basic implementation, nothing special. This was just one of the first tests I wrote. The more interesting one is the transaction test. So this current implementation, just so you have like a bit of understanding what I mean if you work on many structs. So if you just try to do everything in one function, this is all the code to generate the transaction and submit it to the network. So as you can see, you have many structs you're just generating, and then do some hashing, another struct, and here another struct, and you have another struct, here you have another struct, and another struct, and another struct. So you see, working with building classes is way more comfortable than doing this. But this is just, the first implementation of actually creating a transaction and signing it before you go to the actual abstraction you do later on. So this test you see here is just like, just go do it and then submit it, and just that you get like a pass. And the implementation you see here is an actual first abstraction of the things happening in this one function. Okay. Yeah, I think we have quite everything covered. I'm just going a bit through the files and see if I'm missing maybe something. But after that, I would go to maybe the to-dos, or like the things, if you want to contribute to the project, like the things you, which I will highly appreciate to do. So first thing is, of course, doing an implementation of the proto files I've mentioned earlier. So let's see, where are they? Here. So on this repo, would be really nice to have a Rust integration in here, so that we don't have to do the build script into the repo. Currently, it works good, so maybe we don't need that, but if someone has a nice solution for that, it would be really nice. Parallel to that, as I said earlier, the tonic libraries have to be updated so that the proto files are being generated with the latest version. And from there, there's just like implementing the features. There are some problems in the current implementation. So I've complained about OpenSSL earlier and about the normalization of the elliptic curves. So if we look into the, where is it? Into the sign message function. Here we are. So I tried to stay on the OpenSSL crate, which is like common. You don't want to have too many crates, different crates implemented into the project, especially if it's about like cryptographic stuff. But sadly, the ECDS, the elliptic curve signature it generates is creating sometimes a too large signature. So if you have a high S, you have a vulnerability in blockchain systems. And the OpenSSL implementation doesn't allow normalizing the S value in the elliptic curve signature. So what's currently, for example, the implementation is to get another crate. In this case, it's ECDSA. So let's see, where is it here? Which is able to do such normalization. And then what you get is like a hybrid sign message like this one, which is not good. You can see here that we have an OpenSSL ECDSA, and after that we change to the implementation of the Rust crypto implementation there. So these are like some of the things which have to be corrected, but for now it's okay for the early development. Yeah. So some things about the things I've said at the beginning, for example, WASM and stuff like that. So if you want to have the WebAssembly support for the project, we need to keep in mind that this should be modular as far as we can go. Not every library works on WebAssembly, for example, or even maybe on microcontrollers if you want to. For example, some libraries are using, for example, the def random file in Linux, which is of course not available to every operating system or on any controller, especially not on WebAssembly. So as soon as the basic functionality is implemented, would be nice to have a modularity there, so that WASM is being able to be supported, and other architectures, of course, too. Good. Any questions at this point? Why not Rust native Ring instead of OpenSSL? Good question. And I can't answer that. I think it was just an intuitive thing to do OpenSSL. But changing it to Ring would be a great PR, for example. So this is good, how you say it, good suggestion. As you can see, the Tonic crate and as well as Rust LS are already using Ring as a feature. So probably using Ring crate would probably make sense too. Yeah, but I see already great suggestions. So if you want to contribute to the project, now have like a brief overview of the whole project. So if you want to contribute to the project, we have this repo. So this is the fabric-sdk-rust. And of course, I'll send, just to complete it, the chaincode GitHub 2. The chaincode GitHub, as I said, is not yet implemented. but it will be. So if you, I think we will have another meeting talking about the chaincode too. As soon as we have like a basic functionality, so we can show something. So if you want to do some stuff, it's the best is to, I think, to clone it, or to not to clone it, to fork it, and then do a pull request from your fork. There are no templates yet, so this is, as I said, really early stage. And yeah, just do a pull request, and then we see if it's mergeable or not. Cool. So I think this is it. Yeah, I think I've already sent the docs in there. Yes. Okay. So from here, I think this is everything. I hope I haven't forgot anything. So if you have any questions, please, you have a Discord ID here. I think I can send a Discord link to my profile, so to my account into the chat. So I'm open to just, write to me directly. But we also have on the Linux Foundation Decentralized Trust Discord server an own channel. As you can see there, I'll send the link to it into the chat too. So I'll be having an eye on this on the channel. Oh, LinkedIn. Yeah, I forgot LinkedIn. Of course, LinkedIn. You can also have LinkedIn. So just contact if you need like help. I'm really open to get if you like need help getting started into the project. If you're like really new to Rust, just write me. I'm really happy to help. Even if you're like completely beginner, you will find some work there too. Yeah. So, any questions from this point? Thank you very much for the compliment. Really happy that I could get a little overview to you. I hope that I've kind of structured it in an understandable way. But as I said, if you want to ask any questions after that, if you want to need help setting it up, it can be a bit tricky to set up Hyperledger Fabric for the very first time. If you need help with that, as I said, feel free to contact me. I'm really happy to help. Here is also my Discord ID, so you don't have to actually type that in there. And yeah, great. Good. Then have a nice day, everyone, and happy coding.
Great. Thanks everyone for joining. Thank you, Arne, for presenting and sharing about the lab. And it'll be great to see everyone in the community going forward. So thanks, everyone.
Thank you.
Thanks, cheers, bye.
Bye.
Thank you guys. Appreciate you guys.